All right, Mathletes, section 10.2, part 2. We're going to talk about what's called the discriminant. So, first of all, let's start out by solving these quadratic equations using the quadratic formula. So, kind of a review of what we did yesterday. All right, so for this first one, what I want to do is get one side equal to 0 first, right? Already done. So then I can identify A, B, and C. So A is 1, B is -3, and C is -5, right? Have everything I need for the formula. So now I'm going to plug in, and let me write the formula up here, x equals. Anybody have it memorized yet? All right, and so I'm going to plug in, I'm just going to set up my template here. All right, so remember that A is 1, and that goes after the 4 and underneath. B is -3, that goes in the first two spots, and then C goes at the end. All right, so negative negative makes a positive there. So the 3 is going to come down. And the bottom 2 times 1 is 2. So now I'm just going to do this right here, right? So it's going to be 9 plus 20. So 29. Oops. Use blue. And square root of 29 can't be simplified. That's, 29 is a prime number. And so that's pretty much it, right? Can't reduce anything. You could break it up if you wanted to and make it into this, but no real need for that. Okay. All right. Another thing we could do that we didn't talk about the other day is we could plug this into our calculator, right? And we'd have to plug in two. We'd have to plug in one with a plus and one with a minus, but we could plug this in and get a decimal approximation, right? It's irrational numbers, so the decimal will go on forever without a pattern, so we'd have to round at some point, but that's another possibility. All right, so we have two real solutions here, right? Just keep that in mind. All right, number 2, here I do have to get one side to be 0, so I'm going to subtract 3x and add 9 to both sides. So I get x squared minus 3x plus 9 equals 0. And so now to identify A, B, and C. So A is 1, B is -3, and C is 9. So now I can plug them in. Negative b plus or minus the square root of b squared minus 4 times A times C all over 2A, right? So A is 1, so that's going to go after the 4 and underneath. B is -3, and C is 9. All right. So we're going to end up with a similar looking thing. 3 and the 2. Then underneath the radical, this time we have 9 minus 36. So that's going to be -27, right? Okay, so here we have a situation where we can simplify this and we have an I that pops out, right? And so we're going to end up with 3 plus or minus 3i root 3 all over 2. Okay, so here we end up with no real solution and 2 imaginary or complex solutions, right? So 2 complex solutions, no real solution, in other words. All right, so let's check out number 3, the last one. So we had 2 real solutions, 2 imaginary solutions. So think about what is going to happen on this one. We already have one side set to 0, so we can identify A is 4, B is -12, and C is 9. So we can plug in negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So a goes after the 4 and underneath, b goes in the front two spots, and c goes at the end. All right, so we have a negative 12. So that's going to come down to be positive 12. 2 times 4 on the bottom is 8, plus or minus. And so now we're going to do this in our calculator. And it turns out to be 144 minus 144, right, which is 0. Okay, so the square root of 0 is, of course, 0. So we have 12 plus or minus 0 over 8, right, which equals 12 over 8, right? 12 plus 0 is the same as 12 minus 0. So we just end up with 3 halves. Okay, so only one answer there. Okay, so we went from having 2 real solutions to 2 complex solutions or no real solution to 1 solution, right? So let's talk about what determined that, right? What determines how many solutions we have in the quadratic formula, right? So if we look, really it all comes down to this part here, right? Because that's what we're adding and subtracting, right? So if this comes out to be a real number, then I'm gonna have, or excuse me, if it comes out to be, if this comes out to be, what's underneath the radical comes out to be a positive, I should say, then we're gonna end up with a real number, right? And we'll have negative b plus or minus, you know, some positive real number, and that'll give us 2 values, right? We'll have negative b plus a number, that'll be one value, and then negative b minus that number, and that'll be a whole different value. So that's when we have two real solutions, is when this comes out to be a positive, right? Okay. Whenever we have a negative underneath here, right, whenever that comes out to be negative, like in number 2, we're going to end up with 2 complex solutions, right? Because we'll have an I that pops out, and so we'll have, you know, a real number and an imaginary number, and so together that makes a complex solution, or 2 complex solutions because of the plus or minus. And then when do we have only 1 solution, like on number 3? Well, if we look underneath that radical, what happened was we got 0, right? That's the only way to have 1 is if you get 0. So if you have, you know, b, negative b plus or minus 0, that's the same as just negative b itself, right? So those are the 3 scenarios. You could have a positive underneath the radical. That gives you 2 real solutions. You could have a negative underneath the radical. That gives you 2 complex solutions or no real solution. Or you could have a 0 underneath the radical, and that gives you only 1 solution, 1 real solution, okay? So the value that's underneath the square root in the quadratic formula, we call the discriminant. And what it does is it tells us how many solutions we have, right? So it tells us the number of solutions. So it's kind of a an indicator for us to tell us, hey, what's going on with this particular quadratic, right? How many solutions can we expect, or how many solutions do we have without having to do the whole formula, right? And so let's fill in this table. We just talked about this, but if the discriminant b squared minus 4ac is positive, that means we're going to have 2 real solutions, right? If what's underneath is negative, we're going to have a negative underneath the square root, right? And so we'll have to pop an I out. So that means we'll have imaginary solutions, right? So how many real solutions? We'll have 0 real solutions, okay? And so on the side, I'm just going to put 2 complex solutions, right? All right. And then if what's underneath the radical or the discriminant, in other words, is 0, then that means we'll have 1 real solution, okay? All right. So good chart to have in your notes.